My name is Safwan Samsuddin from Lahore University. So I'm a PhD researcher in tech here. So basically, quantitation is more on part of my analysis, my measurements. It's more on thermal comfort, different from buildings design or building measurements. So I found some things from a small data sets that there's a regional difference of thermal comfort. That means people from different countries have been, whether they can adapt in this country, the heated environment. Okay, it's to understand, this small particular presentation is to understand the differences of acclimatized people, whereby like me or somebody from not from European countries in UK, whether they have been the same thermal comfort sensations in the heated indoor, on the indoor environment, whereby you can see outdoor environment will be different, but how about indoor environments? So this is the research concept. My topic is more measurement in residential buildings, and then I'm doing both qualitative and quantitative. So actually here is more quantitative. Why? It's in order to investigate PMV. If you know PMV, the predictive pinboard by Fangers, which is for the thermal comfort index measurements accuracy. So my main study, my main PhD is to find the corrective factor for PMV, and then that needs quite a big amount of data, which is quantitative. And then whether it's suitable for residential buildings, because PMV is being proven that is more closer to a commercial building or offices. But how about at home? And then why I'm doing with different heating system? Because about 80% of residential house in UK, they use a radiator, but somehow I'm going to compare with the other heating systems, whether it's suitable or not, where will it make an impact into thermal comfort sensation into a person in the house. So there's some adaptations thing I want to show you. Actually, in 1936, I found this in the literature by Olsons that Austria already put this statement that it should be kept in mind that southern people were not northern people, with their more sluggish heat production and lack of adaptability, will demand a comfort zone a bit higher than those even in the northern area. So I tried to prove that from my small analysis here. Then I use for measurement, I use the standard, which is the Austria standard, which is more on the position of sensors during my thermal comfort experiments. But the sensor is only mainly for the seated person, because the participant that I had actually all seated and also in sedentary activity. So according to Austria, it should be about 0.6 meter height on the floor. If it's a standing person, it's going to be 1.1 meter height. So the sensor is based mostly on at 0.6 meter height. So there's some qualitative studies, which is the questionnaires for the thermal comforts. And that's based on the 7 sensation scale. It's based on 15 minutes interval, which is being used as measurements or interval in building managements. And the set points are based on the World Health Organization also safety guide A, which is somewhere not less than 18 degrees for other locations, but the location that I'm investigating is more on the living rooms, which is more being used in the house, whereby according to SIPC in winter or cool season, it should be somewhere in between 22 to 23 degrees. So try to investigate whether it is still suitable or not. This is the measurement equipments. There are about four sensors there, and then another 2 environmental, which is for clothing and metabolic rates. And then there's another vertical air temperature pole. Actually, I got 2 of these in the house. So it's to investigate the stratified temperature in the room, whether is it still suitable for the standards that have been stated by ASHRAE, SIPSI, and also EN 15251, whereby it should be somewhere no more than 3 degrees of temperature degree difference of temperature gradient between anchor to head heights, but somehow you can see. So my measurement started last year. So I measured this data basically is based on the small sample set data, because I had another bigger sample of data, but I can't compare in regional kind of point of view or analysis, because that bigger set of data is mostly European. So I used a small sample set of data. We started last year, March 2015. I think Vicky was there, and Ben was there. They're part of my subjects. So thanks. Who else? Anybody here? No, nobody there. All right. And then the second experiment was done last March. So I tried to compare between the same month between 2 years. So with a smaller sample, very small sample, with just only 8 subjects there, because nobody turned up for other sessions. And then all the sessions together were conducted for 6 days, and then it's all started after 15 minutes after they arrived into the locations, which is to normalize the metabolic rate and somehow before they start the experiments. And then I put some control environment here. Even in a real house, people will try to adapt, or they have some different behavior into heating systems because of cost and everything. But somehow they don't have to think about cost of billings or energy bills, and they don't have any opportunity to adapt themselves by taking some like extra clothing or sleeves. Here I tried to put a strict requirement to the participants to wear only t-shirts and also trousers, whereby it's approximately going to be about 0.8 kilo or clothing resistance. And then there's another control parameters, which is I asked them to sit, and then maybe just do some readings or small work, which is to maintain and then to approximate their metabolic rate, which is about 1. That's the burning heating criteria. And then the heating for the radiator, the water supply is about 54 to 60 degrees. So try to investigate whether this water supply is suitable to maintain heat in the house. Because whereby most of the house or most of the home, they set it about 60 to 70, and then that's going to be about a higher side of water temperature. So by reducing a little bit, will be make any difference. And then that's the calculated radiator size, and then the burning heat loss coefficient, which was I did some co-heating tests last year, I think with David's help. So we got around about 137 watts per Kelvin. And then that's the test house. Sorry, I don't have the whole picture of the house. That's the test house there. The exchange rate is about 0.87. It's a bit higher side. It's a bit not too leaky, but it's a bit leaky in the house. Then it was this measurement was measured by Richard Jack, one of our ex-staff. And then I used another heating equipment, which is the fan heater, to try to compare between fan heater and radiator. And then that's the participants from the hot climate control. So you got 3 Malaysians, which is near the equator. So their temperature is about, the country is about 20 to 35 degrees overall for the whole year. And then I got 1% from Kuwait, which is most of the country climate is about 20 to 45 degrees, I can say. So they used to be in the hot climate. And then one region which is also the part near the equator. And then another participant that I compare from the trial recipes from all the British Greek venues. even eastern central China, I put it in the cold climate because they live, the participants, both of them, live somewhere near Beijing, which is a bit higher side, which is going to the northern side of the country. So which is not near the tropical area, it's somewhere. Yeah, that's the location for which the participants came from. So it's a bit higher side, the middle, between the tropical and Arctic Circle. So that's the data, which is both data last year and this year. I got 208 votes for the total samples, and then from 25 peoples, and I got 27 data sets. It's quite interesting. I got 25 people, but I got 27 data sets. But I got two generous people to knock twice. Thank you to Vicky. She knocked twice, and then there's another lady here. I think she's not here. And then total of 18 hours of survey, and average of 20.8 degrees indoor temperature. So I obtained this data from the major air temperature by data loggers, which is the square data loggers and also the Innova kit. And then the average sessional outdoor temperature for both year is quite similar. So it's quite interesting that March this year and last year having the same mean outdoor temperature. But that's only accounted during the sessional outdoor temperature, which is I've counted during the sessions, the thermal comfort sessions being held, or experiment being held, not for the whole day. So these are some of the results that I gathered. It's quite interesting that smaller samples and then bigger samples. But somehow, if you can see the blue line is the actual mean vote, which came from the participants' votes for the thermal comfort, and then that's the PMV. It's quite interesting that PMV for the hot climate is not suitable. Yes, because there's some from the literature review, most of the scholars, they said that PMV is only suitable in European countries, also colder region countries, and then now they try to make some quality factor for PMV in Asia, in some other cold, warmer country. So somehow it's interesting that it really conclude what they say. And this is the result for the cold climate participants. So as you can see, the result is there. There's nearly a degree difference for both set of participants. So, and then if I bring you back to the previous statement by actually 1936, whereby it said that southern people are more sluggish into temperature, where they might need a higher degree of set of temperature. But from the result, with this small data sets, actually they can adapt into the climate, which is being acclimatized in this country, in the heat environment indoor. And then I use another method, because why I use Griffith comfort temperature? Because Griffith is suitable when your data set is quite small, and then many scholars said that Griffith is suitable in their studies with a smaller sample of studies, because there's some statement by Rijal in field investigation of thermal comfort in Japan, where he had 57 of participants, which is a bit bigger than mine. But he used Griffith comfort temperature and he compared with PMV, and he agreed that Griffith is more suitable to his data sets. But somehow, I tried to prove whether it is suitable in my analysis. So this is the cold climate mean temperature of 31.5 degrees. So I thought, okay, it doesn't make sense to use Griffith in my study. Right? And that hot climate mean temperature 29.1. It's still much lower than the cold climate. But somehow the standard deviations, which I compared from the mean indoor temperature it's quite high, 7.7 degree and 5.9 degree is quite high. So I disregard glaciers in my conclusion. So I guess the irrigation method is more near to the average room temperature. That is more improved when we study. So based on the carbon thrust, a degree lowering down a degree of temperature can save about 8% of fuel consumption of heatings. So this is just my short. It's not been concluded yet, but from this analysis, people from our country may save about a degree of that. Yeah. Somehow people can adapt within that tolerance of temperature in that particular house, that particular living rooms, and then in that particular control environment. It's more different between the labs control environment. It's more like, so you have a leaky house, you have outdoor environmental temperatures, and then that might contribute to the thermal comfort. So I think more data needs to be collected for the purpose of the study. It's going to be, I can't miss this because this data will be collected during the colder season, which is autumn, winter. There's 2 seasons, which is like BK, surely winter thing. I mean, winter or colder season, yeah. Right, that's concluded.
The front. A quick question for Safwan.